This is video number 1 for sections 9.3 and 9.4, rationalizing a denominator containing one term. We've talked a little bit about this topic before. Rationalizing the denominator is a fancy way of saying get rid of any radical symbols that are at the bottom of a fraction. So you might remember back in chapter 7 we talked a little bit about this. Radicals at the bottom are considered unhelpful and unsimplified. And so now in this lesson we're just going to look at the situation where the fractions are maybe a little bit more complicated than what we've seen before. Specifically in this video, we'll talk about how to get rid of the radical as long as the denominator only contains one term. One of the tools that we're going to make use of is this rule, which says that if you have a fraction contained in a radical, which is also considered unsimplified, you can always break it up into two radicals, the radical of the top part over the radical of the bottom part. So that's one rule that we will make use of. But our basic strategy as we go through these examples is this. If we can just create a perfect nth power, meaning a perfect square in the case of square roots, or a perfect cube in the case of cube roots, or a perfect fourth or fifth, etc. If we can create a perfect power, then that item will come out of the radical and we won't have the radical down there anymore. How will we do that? Well, it involves multiplication. And so let me show you by working a few examples. I just have several examples here. All of the directions are the same. Our goal is to simplify. We've been learning throughout chapter 9 several ways to simplify radicals, so we want to continue to do all of those things. We're now just adding in this one extra piece of getting rid of radicals in the bottom before we're done with the problem. Okay, so take a look at this first example. 3x on the top, square root 6x on the bottom. Maybe you're looking at this thinking, oh, we should do some canceling here at the beginning. Well, that's no good because this is not really a 6, it's a square root of 6. And this is not really an x, it's a square root of x. Remember how we've talked about before that when you're talking multiply, divide, inside stuff stays on the inside, outside stuff stays on the outside. So I have no way of canceling or anything like that. Really, I think the main thing I need to deal with is the fact that I have this square root down on the bottom. Well, we said that if I could just create a perfect square down here, 6 is not a perfect square, x is not a perfect square, but if I could create a perfect square in there, then I would be able to actually bring it out of the radical. And this part you may remember from chapter 7. The trick was simply to multiply by an exact copy of that square root. Now, that's fine. I can do that as long as I also multiply the top by the same item, right? With fractions, you're allowed to multiply the top and bottom of a fraction by the same thing and not change the value. So let's see what we have now. On the top, remember, outside stuff stays on the outside and inside stuff stays on the inside. So there's nothing I can really do there except write it down. The bottom, however, I do have two square roots. You can multiply two square roots by simply multiplying the pieces on the inside. So 6 times 6 is 36. X times x is x squared. And you see, by doing that, I've created now a perfect square in the denominator so that in the next step, I can actually write down what the answer is to that square root. The square root of 36 has a nice answer. It's 6. The square root of x squared has a nice answer. It's x, because x times x is x squared. Notice what just happened. We rationalized the denominator. There is no longer a radical symbol in the denominator. Just one comment. After you do this for a while, you kind of realize that every time you multiply a square root by an exact copy of itself, you simply end up with whatever was inside there, the radicand, without the square root. So feel free to skip writing down that middle step. It always works the same way. Okay, so is this problem finished? Well, now I just need to look for other ways I might be able to simplify. And see now, remember we were talking about canceling at the beginning? Now I do have several factors all on the outside. Forget about these two guys. This 6 and this x are trapped inside, but these other ones are fair game. I've got an x that divides out on the top and bottom. I can also reduce the 3/6. 3 divided by 3 is 1. 6 divided by 3 is 2. And when I clean that all up and put it together, I believe the only thing I have left on the top is that square root of 6x. And then on the bottom is just the number 2. That's as good as I can make it. You know, I know your brain wants to do something with that 6 and that 2, but remember this 6 is trapped on the inside. We have simplified the expression, including getting rid of radicals in the denominator. Okay, let's try some other examples. So here, when I look at this, what I see is, oh, I've got this fraction inside the radical. That's a little different than the last time. Well, that's no good. We don't want to have that. It's not helpful. It's considered unsimplified. So what I'm going to do is I'm going to use that tool we talked about at the very beginning, the one that says that you can split this up into two pieces, square root of the top over square root of the bottom. The next thing, now you might be looking, oh yeah, we're going to have to rationalize the denominator again, and you're right, we will get there. But I would suggest typically that's near the end in terms of the steps that you're going to do. What I would recommend you do first here is I'm noticing I have some perfect square factors in these radicals right now. I didn't have that before. 6 and x didn't have any perfect squares, but 9 is a perfect square, and 4 goes into 8, so 8 has a perfect square factor. You're going to make your work easier if you simplify the square roots before you worry about rationalizing the denominator. So I'm doing the whole good, bad, radical thing. 4 is good, leaving me with 2 in the bad. Here, the whole 9 is good, but I would need a couple of x's, so the x is bad. And then those front square roots have nice answers. So this becomes 2 root 2 over 3 root x. Now that we've done that, let's worry about rationalizing the denominator, because we've cleaned this thing up quite a bit. It's probably about done except for that rationalizing step. Okay, so what am I going to do? Well, I'm going to take this, I'm going to multiply the top and bottom by the same thing. Is 3 a problem? Is it a problem to have a 3 down there? No, 3 is just a number. It's just the radical that I need to be concerned about. So all I need to do is multiply this by an exact copy of the radical. Whatever I choose to do down there, I do up here as well. And then let's see what we have. Remember, outside stuff stays on the outside, so that would be the 2, but the inside stuff can multiply. 2 times x would be 2x. And then on the bottom, I have the 3 on the outside. And then I have root x times root x. And as we were saying in the last problem, when you multiply a square root by an exact copy of itself, all that's going to happen is you're going to end up with that x. You could write root x times root x is root x squared if you wanted to. And then in the next step, say, oh, well, root x squared is just x. I think we're done with this problem. There's nothing else to do. I'm looking for canceling opportunities. This stuff is trapped in the square root, so that's off limits, and nothing else is in common. So we've taken this problem as far as we can. This would be the final answer. Okay, now look at the third example, and I'm going to change things up a little bit here. This is the first example now that has something other than a square root. Okay, we've never done this before. Still, the goal is the same. I'm trying to get rid of this radical in the bottom. I'm trying to simplify, if at all possible. But here's the thing. My old trick, this trick we've been doing in these other two problems, is not going to work. Remember, if I'm dealing with square roots, then I'm trying to create a perfect square. But if I'm dealing with cube roots, I'm trying to create a perfect cube. Don't write this part down, but if I was to come over here and try multiplying this by an exact copy of itself like we've been doing before, what's that going to make? That's going to make a 16 and an x squared. Well, 16 and x squared, those are not perfect cubes. That's not going to help me at all. So you have to be a little bit more creative when you're dealing with other kinds of roots. The exact copy thing isn't going to work. I need to think about, well, what do I need to multiply by so that I can turn that 4 into a perfect cube, right? Perfect cubes, 2 times 2 times 2, 3 times 3 times 3, etc. Well, I think I can turn that 4 into an 8 by simply multiplying by 2. How about x? Well, remember, to be a perfect cube, the exponent has to be a multiple of 3. I only have one x right now. If I just multiplied by 2 more, so 1, 2, 3 now total, then I would have a perfect cube. That's the goal, is turn the denominator into a perfect cube so that I can actually take this stuff out. Whatever you decide on the bottom, of course, you're going to do the same thing to the top. And so let's multiply now. I've got on the top not much I can do because outside stuff stays on the outside. And then on the bottom, I have 2 cube roots, so I can multiply those two things together, which gives me that 8 and that x cubed. And that's what I wanted, because now that stuff has a nice answer. The top, again, I don't think there's much I can do with that at this point. But the bottom, the cube root of 8 is 2. The cube root of x cubed is x. We have rationalized the denominator. The only other thing I'm seeing before I finish is this stuff on the outside. I do have a common factor here with the 2 and the 4. And so I can go ahead and reduce that. I need to do that. It looks like the final answer to the problem, I've got the 2 and the cube root of 2x squared on the top, and then I've got x on the bottom. That would be the simplified final answer with the denominator rationalized. Remember, it's all about creating that perfect power. Let's look at one last example here. This one has a 4th root in it, and it's going to be similar to what we've been doing. The first thing I notice, let's see, I've got this multiplication problem I'm going to have to deal with. And then I've got one of those fractions inside the radicals, so I think I would break that up into the 2 pieces as we've done before. So that's the same thing as 4th root of 1 over 4th root of x cubed. And then how do you multiply a whole number times a fraction? Usually you put a 1 under the whole number and then you just multiply across. So I think I'll do that. That gives me x 4th root of 1 over 4th root of x cubed. Now, 4th root of 1, that means what number do you multiply by itself 4 times to get 1? That has a nice answer. 1, we don't often think of that as a perfect fourth, but it's a perfect square, a perfect cube, a perfect fourth. It's a perfect everything. The 4th root of 1 is just 1. So this thing continues to simplify pretty nicely. That means I just have an x on the top, and then here the 4th root of x cubed. So I think I'm ready to try to rationalize the denominator now. I'm thinking to myself, I'm going to have to multiply by another 4th root, because you can only multiply 4th roots by other 4th roots. I'm not going to do the exact copy thing. Instead, I need to think about how to create a perfect fourth. Well, with variables, it was just all about having the exponent be a multiple of 4. 4 of them would be great. So I have 3 now. If I can just put in 1 more, then I think I will be all set. So if I multiply top and bottom by 4th root of x, that should do it. That'll give me x 4th root of x on the top. The bottom is now the 4th root of x to the 4th, which has a nice answer. It's just x. And then take a look at this thing here at the end. Before I stop, I look for any common factors on the outside, and I have that x. Now that divides out, this problem has a far simpler answer than we might have expected. It simply works out to be the fourth root of x, period. There's not even a fraction associated with this problem.